Welcome! Let's take a look at using the fundamental theorem of calculus to help us evaluate a definite integral. In this case, we have the integral from 0 to pi of 4 times cosine of x plus e to the x dx. Our integrand is 4 times cosine of x plus e to the x, and both the cosine function and the exponential function e to the x are continuous for all real numbers. So we can expect that they are continuous on the interval from 0 to pi. So we can go ahead and start by finding the antiderivative for this integrand. So we start by asking ourselves, we'll have a constant multiple of 4, and then what is the function whose derivative is cosine of x? That is, the derivative of what equals cosine of x? Well, that function that we're looking for is the sine function. The derivative of the sine function is cosine of x. So we're going to have 4 times sine of x plus, and now we ask ourselves, what function has a derivative who is e to the x? Well, the function whose derivative is e to the x is e to the x. So we've got 4 sine of x plus e to the x. And we're going to evaluate that between x equals 0 at the lower limit and x equals pi as our upper limit. So substituting pi into our antiderivative, we get 4 times sine of pi plus e to the pi minus, and now we substitute in x equals 0. So we get 4 times sine of 0 plus e to the 0. Now, sine of pi we know is 0. So this is 4 times 0 plus e to the pi minus, and we know that sine of 0 is 0. So this is 4 times 0. And keep in mind that we do have to distribute that minus, so this will be minus, and then we know that e to the 0, that is equal to 1. So 4 times 0 here and here are both 0, so we end up with e to the pi minus 1 being the value of that definite integral. I hope you find this helpful.